Okay, it seems like we are live. So, hi everyone. This is going to be one of our guest lectures with Master Krist Wongsuphasawat. Here is he. Chris is a very fun friend of mine from our times in our PhD at the University of Maryland. We had a lot of very good times together. I was always trying to follow his footsteps, which was and has proven to be very difficult. But he has been a great friend of mine. So for everyone that joins, please remember to mute immediately. So without any further ado, he's going to be talking to us a little bit about his work at Twitter and everything he has done in there. And as you will see in a minute, he's a master in design and creating beautiful presentations. So I think we're ready. So Krist, the floor is all yours.
All right. Thank you, John, for the kind introductions. I also learned a lot of good things from working with John back in Maryland. So today I'm going to talk about the things I can learn from doing a lot of visualization projects. Like I think of visualization is a kind of my way to go into a battles. Like every new project is like a new battles, and you can walk into a battle knowing nothing and just try to like bash everything in front of your way until you finish it, or you can try to be more prepared. So next time you may be like going through the battle a little bit easier. And that's the kind of theme of this talk. So what are the things you should expect when you visualize things? A little bit background about myself. I was born and raised in Bangkok, Thailand. I got an undergrad degree there. And then I was interested in two things at that time. One is programming. The other one is soccer or football, actually. Yeah, now I'm talking to Colombian people, so I don't have to use soccer anymore. And I found that I'm pretty suck at like playing it, so I joined a team to build robots to play the soccer, the football. And I thought that, well, I would be building something like this, but I end up helping my friends building something like this instead. It's like a size of a small ball, and it can run around shooting golf ball instead of the actual balls. So one thing I learned from this project is I actually hate hardware. I love software a lot. I end up building a user interface for people to control the robots and tune the parameters for the AI to run. So I came to the US, study information visualization at Maryland. That's where I met John. A lot of good things happened there. After that, like I also got a chance to internship at IBM, Microsoft, and come to work at Twitter since. So what do I do? Like at Twitter, it kind of categorized into multiple things. One is the interactive visualization. It's just like when earthquake happen, the World Cup happen, or something big that is like a recent events. We do something fun, like so the public relation teams can share about it. But most of my time I spend on internal tools because we have a lot of data. So we collect user information. We have tons of tweets, and we want to kind of infer or know how user use our app better. So there are tons of data in here that we can build tools to analyze them. And many of these can be extracted and put into open source projects. But at the end of the day, a lot of people see me like, okay, give me the data and I will turn it into visualization. That's like the kind of general theme. And many times I jump into the project feeling like, wow, okay, give me the data. I'm ready for this. This is going to be great, right? And I was expecting to catch this fish easily, and it turned out to be like that. And most of the time, it's kind of like that. Like it's more difficult than we expect. So what are the pitfalls that will come? The first thing when you start a project is you should expect to find the real need from your target users. Many times people come to me and saying, hey, I have this data, it's like so organized, clean, and you should be able to use it, do something great for us. And what I found is they usually have this and have to spend a lot of time trying to figure out how to make it work. Or when they look at my project and they see that, oh, this guy is a magician, he can turn our ugly data into something nice really quickly. But the most they will get is someone who tried to be Harry Potter. And there are a lot of mismatch there. And sometimes they ask, oh, can you make this like 3D spinning globes with all these fancy fireworks shooting out in all directions? And I was like, well, you actually need a bar chart. So what do we do in this case? We need to communicate a lot, like try to understand, like what do they have, what can we provide, what do they actually need that is like within our power. Like, what are their goals? Are they trying to present the data just to communicate something they already know, or they want to analyze something? This is like, okay, try to find pattern in existing data, or they did a lot of analysis repeatedly, and then we want to build some tools to make that kind of process easier. Or sometimes they just want to have something fun to enjoy, and maybe it's a combination of these goals. So then you can dive deeper into like more specification, like when they want to present data, who are the audience? What do you want to tell? What is the message? Right? If you want to analyze data, then what is the analysis questions that they are trying to ask? If you want to build tools, who will use this? Is this going to be used by engineers, product managers, or somebody who doesn't even know how to write SQL? Then there are limitations of what we can build. And what would they use this for? What would their tasks or day-to-day look like with these tools? And even the enjoy one, you need to know who are the audience. Like if this is for CS students, like our sense of joy is one thing, but if we show this to marketing managers, their sense of joy is like different things, right? And of course, they are mismatched. Like they ask us for one thing, we tell them that this is what you're gonna get. They will not be happy. So we need to find some way to compromise, like in the middle. All right, let's say we clear the requirements. We sit them down, tell them, okay, here's what you have, here's what we can provide, and then we can get to work. We get some data. You should expect to clean the data, or actually, you should expect to clean the data a lot. Why is that? The data scientist roles, most of the time, people joke that it's a data janitor role because we spend 70-80% of the time cleaning the data. And when say cleaning, is actually the more specific term is data wrangling. Can be anything from collecting the data, cleaning, transforming the data into the right format. And the reason it may take so much time is multiple reasons. The first thing is it comes in many source and data format. The data can be some open data set that people put it online on GitHub or on like government website. You can download and use it. Or it can be internal data that is owned by the client's organization. Or is this something that you just collect yourself by scraping Wikipedia or manually typing into spreadsheets? And the data can come in just a standalone text file that's kind of easy to download, right? Like text, CSV, JSON, or even Google Docs is pretty good too. But one format that I really hate is PDF. Like when people say, oh, open data in PDF, I was like, oh, that's extra work trying to get things out of PDF. And sometimes people give you, oh, everything is in this database. But it doesn't mean that everything is organized in a database. Like if you have 100 columns, every column name is abbreviation that you don't even know what it abbreviates for. And the person who named all those columns has left the companies, or there's no documentation. That is like a long mystery for you to solve where things are. And the API is another option. I actually found that API usually have better qualities, but there are also more overhead in trying to read from the API. You may need like authentication and that extra stuff. But once you go through that phase, you get the data that you want. And sometimes you just go to a website and scrape it. And the last category is the big data, and I will go over that in a moment. And you need to sometimes change the format. Like if you have 10 files, 9 of them is JSON and 1 file is CSV, and you need to combine them. So you have to like convert that CSV to JSON in order to be able to combine them. Or sometimes like there are multiple sources of tools for the same thing. Like in hospital, there may be database in different departments for the same patients, and sometimes one record suggests that this patient has diabetes, the other place said he doesn't have one. So like which one is the correct one? You have to go and track it down. And let's say you get the data somehow, and transformation is mostly like it will come up For example, if you store the user location in the database, most of the time we store latitude and longitude. If you want to build a map that is by zip code or by province, by state, that is not something that is stored in there. So you need to map the latitude, longitude into a state, and that is extra work. Or sometimes the database store the country code in the 3-letter format, but the other mapping libraries that you're using needs the 2-letter, so you need to map that. Or if we are trying to analyze users' behavior and we have users from around the world, and everybody's on the different time zones, so if you want to see what people are doing at 8 a.m. in the morning, we have to adjust the time zone of every user to be there at 8 a.m., not just 8 a.m. in the database, which could be nighttime for someone who is on the other side of the world. And that, like, once you dig deeper, you start seeing the issue that comes from data collections. Like the simple case is typos, like typing names wrong, like John with H or without H. And sometimes people put incorrect values. Incorrect timestamp is also pretty often when you send data from mobile to the server. Sometimes when the data got stored, it comes in batch, right? So tons of events has the same timestamp, and when you try to look at it afterwards to see what happened before, after, everything is at the same time, so you just lost that precision. And the worst thing is missing data. Like some things that is incorrect, we can still kind of fix or try to infer what is the correct value. But if we forget to log something for 3 months and then we found out later, oh, we have nothing, you cannot turn back time and start collecting the data again. And the definition of clean data is also different from project to projects. Let's look at this data and ask yourself, is this clean? Who think it is clean? Please lift your hand up. Who think it's not clean? Okay, so this is a trick question. The answer is it depends. If I ask how many reviews are there, right? You can say 6 is already clean in that sense. But if I ask how many restaurants are there, it is not clean because there are so many McDonald's with different spellings. So you have to make sure that they spell the same way before you can answer that question. So this is an example that, like, when some people say, hey, I have already cleaned the data set, you can use it. It may be not clean enough for you. Right? Clean for someone else's problem, maybe not clean for your problem. And once you combine all this issue with big data, it just gets so messed up. Like when I say I work at Twitter, people say, oh, you have access to all the tweets. You're so lucky. You don't have to pay for all those APIs to get access to everything. And I was like, well, I wish I have smaller data sets. Every time it's like such a mess. I'm drowning in data every day. Because the way it works is Hadoop is like out of this world on a satellite somewhere. It's like a big storage with tons of things that are way bigger than you can put on any machines. So when you want to get something, you have to write some weird language to convert that into a MapReduce job that get the data out of those clusters. And at Twitter we use scouting. Before that we use a language called pig. And once you do that, you run the job. It can take anything from 20 minutes to half a day, and just to produce some small data set that is small enough that you can put on your laptop, and then you can work on other things. But most of the time, like once you get a smaller data set, you realize that you did something wrong. You rerun the query again. I often run the query before I go to sleep, and then the next morning I found out, oh, something is wrong. I need to rerun it again. And that's how my days goes, like waiting for the data. And when it's big data, the first thing, yes, is time, as I mentioned earlier. But just a simple task become really hard. If I ask how many tweets are about the Oscars, like you may be able to figure out that, oh, let's filter by tweets that has a hashtag Oscars. But what about the tweets that they forget to put the hashtag, right? like didn't include that, or when the keywords become more ambiguous, like if you want to search about Moonlight, that is a movie, you cannot easily tell if that is like just people saying about regular moon or talking about that movies. So when you say any count from all the social media about, oh, there are X people talking about this topic, or X tweets about, or X Facebook posts about this topics, is never 100% accurate. Like the only way is 100% accurate is having people reading through all of them, which is impossible. So most of the time it's like a conservative guesstimate. It's like try to do the best to count those things. Just counting is really hard, and like the data set is really hard, like really big. So you to get it out of the Hadoop cluster, you need to figure out which part you want, aggregate and reduce the size as small as possible, and then use it. So with this, like you don't see everything, you need a lot of time to get it, and you need to throw everything that you think are not relevant away. So it's harder to spot the problem that is in the data. Like one case is I was working on the Game of Thrones project, and there was one character named Ramsay Snow. The way it was spelled in the movie is Ramsay with A. So I was running the query of how many people mention Ramsay using A all the time. And then one day I was like, well, what if people misspell? How many people actually do that? So I just run another query, including Ramsay with E too. And it turns out that yet almost the same amount of people use Ramsay with E. So I had to redo my whole analysis because I wasn't aware of this fact in the beginning. And this new issue can show up anytime. It's like merciless. It doesn't feel like, oh, you are almost done with your project. New issue will not show up. No, it doesn't happen that way. Like many times I was about to close a project and then somebody asked me something about the data that I wasn't aware of. Then we go back to step one again. There was a time when I was making, I think it was NBA or NFL map, I don't remember, but it's like a map of fan base in the US for sports teams. And everything looks nice, like the graph, the map, like we get the data in, the color palette and everything, show the patterns of teams. But then I sent this to my PR teams to look at, and they were like, why are there so many people in Kansas? Like Kansas is like not a really big place in the US, but somehow there are tons of sports fans in that state based on this data. And when we look at the number closely, it's actually more than the number of population in Kansas. So we tracked this down and we found out, oh well, when we assign users to a state or like a particular location, if we don't know anything else other than the country, we just dump you into the middle of the country. And Kansas happened to be in the middle of the US. So any users that we don't know what exact state they are in are dumped into the central. So we have to exclude that data points and figure out how to like do it. So like from all these crazy issues, my recommendations, if you work on this kind of project, is always think that you have to do it again. Like at least you document the process. You put a note down that, oh, I did this small fix to the data set. So if you need to go back one step before it, you know what else needs to be done afterwards. Or if you can write a reusable script, then that would be great, because like when you change the original data, you just like run the script again and it produce the final output. Other than you having to do like all the manual tasks, you may think like, oh, this is only like 5 McDonald's, I can manually correct it. But then you change the data set 10 times, and that's like 50 manual corrections, and you will regret writing a script for it. And once you have a script for one project, like the next time another project comes, maybe you can reuse some of those. And once you have the data cleaned out, which is like 80% of the time, right? Now it's time for trial and errors. And most of the time when you jump into coding visualization, it's like, is this going to be legend? Wait for it. No, it doesn't work. It doesn't work at all. So it happens, don't kill yourself over it. It's pretty normal that like when you think that some idea is gonna be great, if your data and you start coding is went terribly wrong, and like you feel like this is like the end of the world, this is not working, my solution sucks, data doesn't show anything. Give it some time, like you eventually come true. And instead of like cursing yourself for anything not working, you can celebrate your failure. There's a hashtag on Twitter called D3 Broken Method that people just post their failure together. It's pretty good, and you can enjoy the ridiculous quiz that you made that way. And once you have enough painful experience, when it start working, I think that's like the best part. Like when you see the whiz showing the patterns for the first time, I think that's like the best feeling of like working on these kind of projects. And of course, like nobody will let you do this trial and errors forever. We need some kind of push. Like otherwise, you can take the whole year for the whiz to be done. So setting deadline is pretty important. You can set the deadline for like certain steps, like we need to have data set clean by this date, and then you have to have prototype by certain dates. And usually that will push things along. Like you start seeing what is important, what is doable, and then start like producing something. So let's kind of take a little break out here to show to see some of the projects in depth. The first one is a project that I did around Game of Thrones for the public relations team. And this was like before season 6, I think. Like we were talking about, there are tons of people like talking on Game of Thrones, talking about Game of Thrones. So maybe we should do something. And the type of this kind of project is the deadline is more strict. Like they want to send it out like within the first few weeks of the seasons, because if it is getting later and later, then attention of the fans are less and less, and it doesn't worth doing it anymore. And this would be for wide audience. I will not get a chance to sit down behind everyone and explain how this thing works, so it should be somewhat self-explanatory. And it's a one-off project, so you can hack a lot of things and just forget that like you did a lot of crimes there. And the scope is from like come up with an idea to the execution of putting it to a website. So when we start this, we were like, let's start by thinking about the problem that we want to like solve with the data, rather than thinking about specific format of the output. Like not saying, we want to make a map, we want to make a network graph or something. We think about, okay, what can we actually like tell the audience that is unique to Twitter, and like and show our values while being fun about Game of Thrones. So we want to know like what the audience talk about a TV show. Like if there are 20 million tweets about this show, like what are they talking about? Like, and any of you watch Game of Thrones? Can you can you lift your hand up if you have seen Game of Thrones before? Okay, good. And I can go over a recap of the story a little bit just to give a context. So Game of Thrones is based on the book series A Song of Fire and Ice, Ice and Fire. It's kind of medieval fantasies with knights, magics, and dragons. And the brief storyline is there was a king, and the king dies, and then once he dies, tons of contenders like try to kill each other to claim the throne. All the lords is like gather their troops and saying, "Hey, I'm the rightful king," and then start killing each other. And once you watch it enough, you will start to see that the minor characters with actually no power or claim to the throne just make the big ones kill each other, so they have more and more power. So that's pretty typical for like most of this story, right? But the interesting thing about Game of Thrones is that if you see any character that is brave, honest, honorable, that is like a hero of the other stories, they will die pretty quickly. But if you see any character that is intelligent but shady, like or a character who knows nothing, they will continue to live. And when you think that this story is pretty messed up already, this is not enough. The writer say, well, when humans are busy killing each other, he sent more zombies coming from the north, trying to kill everyone. This group doesn't speak, doesn't talk, just kill. And there's only a handful number of people, about hundreds, that only care about this group and try to prevent the humanity from being killed by all these ice zombies. So, as I mentioned earlier, there are tons of characters, and because anybody can die, every episode has many talking points, many different story arcs, and characters to follow through. And like right now, it's actually 66 episodes, something like that. So the ideas that we went through when we start on this project was like, oh, what can we do? If we look at just the common word, think about like kind of word cloud-ish visualization for these tweets. There are too many, like too much noise. Like people complain about violence, nudities, and like those things about Game of Thrones all the time, but like that's not that interesting. So we think deeper and like when we watch TV shows, like what do we care about? We care about the characters, right? Like so maybe we can start by seeing how often each character will mention in the tweets, and maybe that will show us the key people to follow in each episode. So we start by pulling some sample data instead of going to Hadoop directly. Let's get this from the tweet API, and then do some basic entity recognitions, which is me opening a spreadsheet, type in the name of every characters, going through Game of Thrones wiki and like copy paste all the different spelling of all the characters and try to do pattern matching in the tweets. Like if you see a character name, then okay, that's one count. So in the end, you kind of get the sample data that is look like this. So you have character names and you have count. Like so now, what can we do from here? We can put it in a bar chart that show the most popular character in each episode, something like that. Like where can we go from there? So we look around and then like look at other people's work. So this is the work done by The Guardian and Google Trends. So they look at the search volume for particular characters over the episodes. So they have some key characters and like see how popular they are over the episodes. So I was like, well, we can replicate this, but then it won't be so original. So we want to try something different that is like unique to Twitter. So we look at the tweets closely and found that people use emojis a lot in these tweets. Like when they are sad, they are happy. Um, and also sometimes they also talk about multiple characters together. So that's something unique that I think like people will do it in when they search. So maybe we can expand on this idea of showing insights about what people think about each episodes and show the emotions and connections about the characters. So in addition to counting just individual characters' appearance, we also count how many times two characters appear together in the same tweets. So we get the data set that looks like this. There's like the graph data set basically, like we have the nodes being the characters and the links being the pair of characters. And then once we have this, the kind of more natural way of working on the graph data sets is you use a node link diagram on a force-directed layout, right? You have a node being characters, links being the connection between characters, and then add the physics simulation. So then there's connection, they will pull each other together, and hopefully we will reveal us some patterns. So that was the idea. And this is like the beginning phase. So when I dump the data in, I hope that it will work out, and this is what I get. So everything tangle. I mean, yeah, we see the circles, but we hardly see any patterns. So we need to figure out a way to make this like more readable. The key issue is occlusion. First, I reduce the edge. Like if somebody's are mentioned together only once or a few times, we just get rid of those. And then I manually move the nodes apart. This is like me being lazy and drag things around and hope that like this will work out. It doesn't work out. So I came back and try to be more rigorous and add a collision detection. So each circle now will be aware of the other circles around it and will kick each other apart, just to make sure that nothing is overlap. And at least now you can read all the labels and you can see the emojis below each character names, which is what the fan thinks about that characters in that episode. And then we add community detection. So characters are closely related. We will have a contour or group regions around them. And then we push the contour apart. So now this is one episode and it's starting to show like the patterns. Like there's a group of characters like in the bottom right there's Hodor with Bran, Nice King, Eddard, White Walkers, and then the other groups, and it kind of corresponds to what happened in the storyline in that episodes. And we also notice this strong link between Tormund and Brienne on the left, the pink clusters, that has a very thick line because the fans mention them together a lot, and it all come from these scenes. So Tormund is the guy on the left, Brienne is on the right. He just smile at her, and the fans just ship them together. So there are tons of tweets about that.
Krist, was that data only for the later seasons? Because like or were you considering like all the seasons for that network chart that you show at the beginning for the
That one
Hairball?
is episode by episode.
Okay, for
We
episode.
do,
Okay.
yeah, we do it. Yeah. Okay, so yeah, that was like it, and there are also like kind of little details that like went into this network graph. Like one thing we use for drawing the region is called convex hull. It's like trying to draw a shape that encloses the points, right? But the convex hull algorithm doesn't consider the points radius, so it treats like every point as the same size. So if we have one circle that is really big, it will go beyond the boundary of the convex hull. So I have to kind of hack this by saying, oh, you have a dot, right? Let's expand it into the fake dots around it before passing it to the convex hull algorithm. So the convex hull will be expanded to enclose the outer dots. So this is how it worked for one episode. And remember that we still have 60 more to go to. So this is the time when I say, okay, sample data for one episode is enough. This is when I go to Hadoop and get everything else. And Game of Thrones air every Sunday. So how much data would we need for each episode? Do we get the whole week of data Sunday to Sunday? Or do we get 5 days, 2 days, a day? How much should we get? So we can just make a random choice, or we can be more data driven and plot the amount of tweets over time, right? And from this graph, we look at it and okay, most of the time, like after the episode air, within 48 hours, that is like the majority of the tweets about the episode. So we only need about 2 days of data instead of processing 7 days of the data, and that will save us a lot of time and cost. So once we have the data for all the episodes, now in the visualization, once we switch from one episode to the others, this is a basic behavior that D3 will give us. Boom. It's like everything goes in different way. There's no whatsoever relationship between the previous frame and the current frame, and you lost all the context. So we need to fix this as well. And this was like not like expected. At first I was like, well, I get the data for all the 60 episodes and I should be able to call it a day. And then I look at this transition and I bang my head against the wall, thinking like, oh, how do I fix this? So we need to kind of store the old position before like the existing ones instead of randomizing the location for everything and then only assigning the new positions for new character that like is based on the existing one. And there's also crazy things like if you have a cluster that has 2 characters and then it became a cluster with 4 characters, the default behavior, the shape transformation, it looks really weird. So I have to manually say, okay, let's shrink this thing into a circle and then slowly expand them outwards. So it will become a more smooth transition like this. So this is the graph, right? And then if I go to the previous episode, so now it doesn't bounce around as much as I showed you earlier. Like you can clearly see which existing node went from one episode into the next episodes, and you didn't lose all the context.
Krist, did you use any custom-made code for doing the skull regions, like for the communities?
Yeah, it's like I use the D3 convex hull thing, but
The
like
Convex
before passing the point, I intercept and like make 8 points from 1 point using the radius.
Okay, perfect. Thank you.
And we also change the color palette. Instead of using the default one, try to use the palette that can encode the meanings of the story better. And then once we have this is like the visualization, but we cannot just put this on the page and then hope that everybody will know how to read it, how to use it. So we start to add the legend to explain what are the colors, have a control for changing the episodes. And in case that people cannot read the graph, there is like a list that explain here are the most mentioned characters, the emojis associated with them, and the percentage. So at least they should be able to read this list if they cannot read the graph. There's advanced control, and in case that like people do not know what this show is about, or even people who are fans but haven't watched it for a year, forget what these are, we copy the recap from Wikipedia and put it here and highlight the character names. So when you move the mouse over any particular characters, it shows the actual paragraph that has that character's names. And there's also like 2 tips and such. And so yeah, and the demo is like live right here as I showed earlier. You can kind of also move things around, see the different arcs. It's more fun if you are the fan of the shows. But the nice thing of this one is also it's not only for desktop, but we make it work for mobile as well. So in mobile, it will be like shrink and everything move around to fit the device. Yeah, that's about. Okay, so once we ship this thing, like we need to kind of evaluate like if we actually do what we aim to do in the beginning. So does it solve the problem? Like we as a fan feel that we did see a lot of relationships and storyline from the TV shows that the fan feels, and we can clearly see it from these visualizations. And we also add Google Analytics to track page view, how many people view it, and like which websites or blogs like cites it. And I kind of follow the referrals and get into one of these forum that somebody posts a link, and then the next guy said, "Hey, I've been playing with that thing for 30 minutes already." So I found that a success. And not only that, Gizmodo and the next web also like say something along the same line, like warning, this is highly addictive. So it's pretty good. So that was kind of like more on the fun side projects. The next one I'm gonna talk a little bit more about a more serious project, I guess. That's like is helping people here do their work. So this kind of project like are usually richer and has more features because the users are engineers, data scientists who are more technical and know what they're looking for, and like also care a lot about accuracies. Like in the Game of Thrones one, if I miscount percentage of how one character is mentioned, nobody's gonna kill me. But if I count the number of users wrong or something like that, it's more serious for business. And project that once we ship, we need to keep maintaining it, fix bugs, or like do like feature requests. Most of the time, the data analysis process kind of goes like this. Like we have data source, right? And the data scientists will go and like get the data to explore, find patterns, either to like do some analysis or get some intuition for building some models. And like when they use a lot of like random script that they write every time, we found that there are some tasks that they do repeatedly, so we can build tools to save them times instead of them having to write a script to do the same thing over and over. If there's a tool that people can just like go and do that task instead of figure out how to do the same thing that the guy before did. So what are the user activity logs? Like why do we log this? We know that there are tons of users who use Twitter, right? And when the product managers want to think, okay, what would be the next thing we should add or change in here? We want to know how they use it. But we cannot sit down behind everybody because that's like too many users. So we tell engineers to instrument the client. So when you press a button, when you change a page, when you load something, we log that in our database or storage, which is Hadoop in this case. And then what can be logged? Like the most common thing that you can do on Twitter is you can tweet, but there are also other things like location kind of matter. Right? If you tweet from the home timeline or you tweet from the search page, you tweet from the desktop web or you tweet from iPhone, Android, etc. And there are other event activities like sign up, log in, retweet, like, etc. So there was a way that people, even before my time, organize these events. They call it the client event. Each event has a user ID, a timestamp, and then they name the event, trying to capture a lot of information in there. Like there are 6 parts to this: client, page, section, component, element, and action. And the client is like web, Android, iPhone. The page is like home page, search page, profile page, and such. And then the section component element is correspond to the UI component on the page, and the action indicate the user intent. And event details is like a wildcard field that you can put any custom object. Like for the tweet action, there may be tweet ID in there. But the important part, if you want to remember, is like the third part, the event name that has 6 parts, because just the event name alone can tell a lot of things already about this event. So it seems like we have a kind of nice plan. Like once we look at the log data, it should be great. So once the product manager asks the data scientist, hey, let's do some analysis. Tell me about these users. What did they do on our platform? Then they go into the storage and try to find what they want, and then found that, well, it's not that clean. It's like somewhat organized, but a lot of things are messed up there. So yeah, let's say we get over it, we clean it. So we found that some missing data. So the engineers need to monitor it. Like we found out if we don't monitor them, then it's 3 months later, something is missing, then we cannot fix it. We need like a daily thing that we can quickly check if something goes wrong. And let's say once we can do that, then we can analyze it. So there are like a lot of opportunities in here that visualization can help. The key one that I want to talk about is to find and monitor these events. Like we have, as of now, I think it's even more than 50,000 type of events based on this naming schemes. So that's like really, really big. And each events, let's say you count how many times it occur every day. So that means you have 50,000 graph. Any human, no matter how hardworking, cannot go through all this graph like every day. Even if you do that, like you spend the whole day doing it. So we need a way to let people see and like find all of this quickly. So we try to think about a way to make people aware of this whole data set in a better way. And if there's a way that we can make people see what is going on with these events, that would be great. So we think of it and seems like, how to visualize this client event collections. And based on the naming scheme, we found out, hey, there are some structures in the name, right? If we take two events, like iPhone home impression, which is when people open the home page, and iPhone home tweet click, which is when people click on a tweet on the home page, they share the prefix or the earlier part of the naming because they are on the same client, the same page. So we can build a tree data structure out of that. And we can do this not just for these two events, but we can do this for all the events because we have this kind of hierarchical naming scheme. And if we have a tree for today, we can compare to a tree from 7 days ago. And then we compute the difference in counts, and we can see how each event goes up or down. We can use the color to encode it. If it is blue, means it's increased, red means it decreased. And then we can figure out how to display this tree. We try different things from just the node link diagram you see here to tree map to other options, but we settle with this icicle format, which is a variation of how you represent a tree data. The height of the rectangle is proportional to how many times that event occur, and the parent is on the left, the child is on the right. So you can also read the event name quickly. And this is the actual tool. And because I cannot show the actual data, this all fake data on our lovely client, banana, mango, and strawberry instead of apple. And once you look at this, like let's say this is beginning of the day, and we wonder like what is going on, what increase or decrease. You can start look for the part that has dark blue or dark red. And in this case, I noticed this dark blue here, so I can click on it and see, oh, banana API attempts increased by 100%. So it seems like this was a new event that was added in the past week. And the error went down a little bit, but it's not that concerning. And I can close it and also look at, oh, the mango clients overall has increased because it's kind of blue, and most of the time it's come from this results get initial because it's dark blue. And the use case for this is like there was one day that like everything just went right, so like we have to suddenly like try to figure out what is going on, and it's a very good sanity check when you like have tons of things to care about and just seeing, oh, if it like blue or red across the board, maybe some critical thing is going on, like if we forget to lock everything, something like that. And you can also use this to search for event. Let's say I want to search for retweet action. Right? I can just filter like, oh, there are more on retweet. Maybe I change favorite. Yeah, I can type the event name and then search for that. So this is also how people try to look for the events names that they are interested in when they want to do some analysis. Let's say we want to do analysis about the timeline, like then we can like see what are the events that are related to the timeline.
Krist, can you share a little bit about, I don't know, I mean, I understand that this one is a privative software, but can you share a little bit about the architecture you use for building this?
Yeah, sure. So the data in Hadoop, we have a scheduled job every day that take that data, process the count of like it's like event and count and store it in a database. We use Vertica, but you can think as of it as a MySQL on steroid or something like that. And then we have web applications that read from that database. The backend, we used to use Rails a lot. Now most of the things in Twitter backend are in Scala. And then once we get that, the front end, this one was built in Angular, but it was all now everything is in React. And the width here is D3. Okay,
So this one is attacking directly Vertica. So, or do you have like an export daily or something like that, and then you work on that one?
The data is in Vertica. Yeah, the
Okay.
export the daily is just in Vertica. And this just
Okay,
hit that, and we can like add index or cache just to make things fast, both on the server side and the client side. And yeah, so that was it. I'm gonna skip this one. And okay, so for this kind of projects, like yeah, it also takes time to identify the needs, as I mentioned earlier, and we try to design a prototype around the sample data sets, and because it's like has to work for a longer time, so there are more engineering work involved. Like the Game of Thrones one, the data set is like one JSON file, and like you can do a lot of things to hack and make sure that you produce that JSON file, and that's it. But for this second tool I show you, this one has to connect to database as John asked earlier. So like there are tons of things that really need to be done to connect to those things and be able to queries. And we have to write documentation and do internal release, like explain to people how it works, go demo to different teams in hell like office hours or things like that, and maintain a support if it's down, if it has bugs, if something happened, like we have to take care of it. So that brings us back to the expectation number 4. Expect time for refinement, and I think this is like one of the things that separate good and great work. Like, and that's why I share a lot of details about the Game of Thrones project, like the expanding points into multiple points to trick the convex hull or the transitions. Those things are like if people don't mention it, like you may not know that there are a lot of work that went into that, but it's kind of like the extra effort that makes the work like really good. There's a series of blog posts by Andy Kirk on the little of visualization designs. So if you are interested in like all these little tiny details that are often overlooked, but it's really great, you can go read those series. And also my wise man say that the first 90% of the code takes the first 90% of the time, and the last 10% takes another 90% of the time. So allocate some time for refinement. It may take longer and more effort than you expected. And once you do these projects, you should try to find ways to get feedback, because like if you do it, you call it a day, then you will never know how to get better. Like one thing you can do, like during the development, try to get feedback session with either potential users or at least your peers to get some opinions, rather than developing in a cave and like come out once everything is done. Sometimes it may be like not what you expect. After release, you can do like I usually add Google Analytics to most of my public projects, so at least I know who like access it. You can even add like tracking to when people click on buttons and do things like that in Google Analytics. So it gives a little bit more idea of, hey, I have worked so many hours on adding feature. Do people actually use it? Things like that. You can do user study or like try to sit down with some users and ask them to use it, and that will give you better idea.
Chris, about that, like we all know about all of the frustrations from the New York Times with their users not using their interactive parts of their visualizations. Have you found anything similar to that on your basis?
I think there are some like controls that are gonna be too advanced for like people to use. Like the Game of Thrones one has slider in the bottom. I don't think people touch it that much. But the useless interactions but fun, like dragging nodes around, people do it a lot. Or there are like the obvious control that people will like use, like changing the episodes and such. You can also see which episode people look at the most, something like that. Yeah. And like, yeah, if you get this feedback, because like eventually if you want to do this like longer and longer, you want to improve, right? Like there will be more projects, there will be harder challenge, and you need to be better, because like time is limited. If you can only do the same amount of work, like how can you like be better next time? Like one thing is learn from the past. That's why I kind of had to compile this series of mistakes, expectation, pitfalls, so like at least you know what to expect, so you don't end up in a rabbit hole like fixing the same problem again. Like maybe if you work on a project and you found that, oh, there's something that I'm lacking, like I don't know how these things work, and it would be nice if like I know that, like so that the next project you will be readier. And maybe if one person is not enough, maybe two, maybe three would help, having more person, but it also add the overhead of like communications and like trying to make sure that everybody is on the same wavelength for the projects. And you can also work on improved toolings, like writing some reusable libraries that can be reused. One thing that I did is a library called Labella JS. This come from a lot of frustration on working with timeline. I work on timeline a lot, and like trying to put the points on the line and just showing the label what each point is such a painful thing, because when the points are too close to each other, the label just overlap. Like in this case, look at this timeline, like this line, right? There are tons of dots, and each rectangle here is like a text label, and if you put it directly under, they will overlap when they're too close. I used to like manually assign location, like, and then if I change the size of the timeline, everything is messed up again. I have to go to every point, change the pixels. That's not fun. So we built this library trying to actually solve it. So if yeah, so this is like the library that given points and labels, it will find a way to place a label in which it will not overlap with each other, and you can like yeah, no matter where the points is, it find ways that they will not overlap. And it's a variation of the force directed approach. So each label will push each other apart. And I put this thing out, and there are people who even like play with it in like tons of nodes, and oh, you can produce this weirdly beautiful labels with 100 nodes. I think I will never use that in any like real project, but it's kind of fun to see. I think people were trying to break my thing. Like that's why they do that. But yeah, see, 200 still not too bad. That was it. And then, like we also open source a library called D3 Kit, which is like a way to rewrite reusable components in D3. You can check it out. Another tool I kind of recommend if you do allow like a web project is Yeoman. You can scaffold projects easily in like one or two command line. Like when you set up a project, you have to set up like Webpack, set up your HTML page, CSS. Even if you use Create React app, it's still painful. Like, but once you have your own setting that you really want, if you create your own generator, then you can kind of start a project in a pretty quick way. So once I call like Yo, which is calling Yeoman, and I say I want to create a new website, it will ask me for tons of information, and then it will just scaffold the projects and like add all the file that I need to start a new project here. And like the next thing I know, I would be start writing the code already without worrying about setting up all these things manually. So in summary, like when you work on these projects, expect to spend some time to find the real needs of the users. Like there may be mismatch about what they think you can do, what they think they have, and what they think they need. Like once you can identify those, then make sure that they are on the same page, and then you can work to the next steps. Like get the sample data, and or if sometimes if you need to collect the data yourself, expect time to clean, transform, massage, or fight with the data a lot, and then go through trial and errors. Maybe this visualization plan that you have in the beginning of using force directed or some fancy visualization may not work out. You may have to find other ways around. Give it some time. Don't get too stressed when it doesn't work. Celebrate with the D3 broke and made art hashtag, and set yourself some deadlines, and like then you like find a way around it. And then once you are close to the end of the project, expect to spare some time for refinement. Like changing color, font size, etc., and find ways to get feedback, so you can improve for next projects. Right, so I think I will kind of end here, and if there's any questions I can answer, I will be happy to do so. And yeah, thank you for like my colleagues and my wife for letting me making these slides when taking care of the baby.
Thank you very much, Chris. That was wonderful. Really appreciate that. Do you guys have any question back there in the classroom? So, yeah, I think we are figuring out how to fix the audio problem in the classroom because we have two microphones in there.
I see.
Do you guys, I mean, if you can either use one of the connected units, like one of the connected accounts that are directly on the Hangouts, or if you write it on the chat, then I can read it. I see some people trying. Yeah, Sebastian is asking if you were able to access all the information from previous seasons of Game of Thrones because you had internal access to the data.
Yeah, the public visualization that I showed like has information back to season 1. But in the earlier season, we didn't have emojis. I think it wasn't that popular at that time. Around third or fourth season, there will be more and more emojis. Yeah.
Did you, in that case, did you normalize the data in a way, like kind of getting the maximum and then?
The size and everything is kind of normalized by episodes, so it's
okay,
yeah,
like the maximum of the episode.
Yes.
That is kind of a typical thing that you guys do in Twitter, Google, and all of that. I remember the piece that you made for the World Cup and for the how you say the MLB, not the MLB, but the Masters League, the soccer one that you follow.
The Champions League.
That you created all of, yeah, the Champions League. Sorry. So I remember that you created your beautiful string graphs in there, but you didn't include any actual numbers on how many tweets. That's kind of a normal practice that you guys doing. It's like you're showing a relative thing, but not.
Right. It's like more, yeah. If it is like open data set, I probably include everything in there. But like in this case, usually sometimes like there's like competitive advantage and other things that we are not aware of. So we give out as much as we could by like being also conservative on those aspects.
Good, perfect. Fabio is also asking, how long did it take you to build the Game of Thrones piece?
I think for the initial
90%.
idea, yeah, the first 80%, it's like two weeks or something, and then like the next 2 weeks or more, it's like, yeah, those are the 10%.
That's good. But you were working on that like just in your after hours, isn't it? Kind of.
At first I started from the after hours, and then I show it to them, and they were like, "Oh, well, this is actually good." So I get more time to do it in my like office.
Good, good. Perfect. There's also a question about why was the type of device used, iPhone, PC, etc. Why was that relevant for the visualization, for the bananas one?
Because like the logging is done kind of separately on each client. You would expect that like, well, it's actually the app design first, like so even though the web version, the iPhone version and Android version has kind of pretty much similar set of feature, but it's not like exact same from like, because of the limitation of the kind of OS itself, like Android apps and iPhone apps kind of operate slightly different, so they are different in the namings and everything. So like the first separation for every event is like, okay, which platform are you on?
Good.
But
That's
like
perfect.
things like iPhone, iPad are pretty much similar. Yeah.
Yeah, and in a way that also allows you to see if you have an iPhone bug or something like that, and you want to track that, I guess.
Yes.
Good. So there's also another question. How do you normally achieve the mobile compatibility with in D3 for all of the visualizations you're doing? Like that.
So yeah, usually it's like sometimes it's a stripped down version of the Wiz. Like it may not has everything that like the desktop version has, like all those fancy interactions or like tooltips may not work the same way on mobile because they're not that much space. And it's kind of also like semantic zoom, a little bit like the basically like resizing everything to be smaller while still being like readable, maybe recite the node but not the labels. And I also have a lot of if else on, like if the device size is larger than this, it's like a step function, then like I tune all
They
the node
just
size and everything. um, so yeah,
did
it's
you
not ideal, but
did you manage to achieve at least half and half or maybe more visits on your visualizations from mobile than on desktop?
could you repeat the questions? I'm not sure
Yeah,
I
I
get.
was wondering if you were getting more visits on and more interactions, more
Oh,
importantly, on mobile
a lot of
than in
visits
the.
come from mobile. Yeah, like people at on the bus or like
Yeah,
doing
especially
random
because it's
thing.
Twitter, I'm guessing.
Right. Yeah, a lot of traffic come from mobile. That's why we need to add that support.
Okay.
Yeah.
Yeah, I was wondering if you at least reach like a 50-50 for your visualizations.
Yeah, maybe. Or maybe even more than that. Yeah.
Or
I have to check
even
the number. Yeah. But if usually there are tons of traffic from mobile.
perfect. There is another question about like, and this is a little bit off topic, but do you have any suggestions on how will you address the problem of analyzing text data, I guess, from Twitter that it's not in English? Like say that the students are working on, there are like a couple projects at least working on Twitter data, but of course in Spanish. So do you have any suggestions for them?
Let me think. Well, then how deep are like you doing? Like, are you doing like topic modelings or those things, or just like counting?
So, for instance, like something you could give us a lot of insights is that at least one project is working on trying to detect robots on Twitter, like bots.
Mm-hmm.
So, do you have any specific one for that? And then the other one, it's like we have been discussing a lot the problem of sentiment analysis for
Mm-hmm.
Twitter data, especially in Spanish, that it's so rich that it's kind of very difficult for that. So I guess they don't have like a more specific than those two use cases, like bots and sentiment analysis,
Mm-hmm.
unless they correct me here. But do you have any suggestions for them on that?
I don't have like particular suggestions, but I think it would be as just like another text data sets. like yeah, you may have to train a different models for like maybe first classify it by language first, and then like go into like the specific language models to use sentiment, rather than trying to be one like universal sentiment model that work across language. I think that's harder. Maybe like once you identify that, oh, this tweet is in English, use this model. In Spanish, use another model, and just train the Spanish model one.
Perfect. Good. Do you have any patterns or any suggestions on what um, to make your visualizations more engaging, like to increase user engagement on your visualizations?
I think like the understanding the trying to put yourself in users' shoe is like the kind of key, because sometimes like when we work on just, oh, this looks nice, or like get some stories, but it's not that like relevant to the people who look at it, then it doesn't feel like kind of personal or engaging. Like when you look at the business like 3 step, like first like kind of what is it showing, what does it mean, and then what does it mean to me, right? And for the Game of Thrones one, like that one, I'm also a fan of the show, so like I can kind of, oh well, I would like when I play with it, I feel like I want to do this more, or like, oh, why would I care about this thing? I don't want to do that. Then I just go in different directions. But yeah, I think understanding like the people who will use it will help a lot. Yeah.
So yeah, definitely defining users and tasks.
Mm-hmm. And less is more. Like when you do this kind of like public, it's like maybe you don't have to have 100 features, just the 10 or 5 that like actually fit the mindset or storyline.
Yeah. And there is another final one. What tools or coding languages do you use for cleaning the data? So you use Pig for querying.
Now we use
Hadoop.
Scouting. Scouting is a library on top of Scala, but that's mostly for getting the data out. Once it comes out, either Python or Node. Sometimes I use Node just for when it's already small, because like the script is like I already work with JavaScript almost every day, so like writing a Node.js script is like pretty like easy, and I have to do context switching for multiple languages, and I can write the code like in an independent way that, well, at first if you thought that this cleaning will be done on the website and you can want to move it to offline, it's less like almost zero work, right? It's the same piece of code.
Good. And I have another one that is kind of interesting for one of the research testings or thesis that we are doing, is that for testing, do you use anything specific for doing testing on your visualizations? Like, or do you do everything manually?
Yeah, there's no automatic on the Wiz part at the moment. I have unit tests for mostly the models and like computation or logic side. That one I use like unit tests. For the component, the most I do right now is like using a React Storybook just to like develop the component in the sandbox, but there's no like testing or anything like that, that, oh, you put this data, you should see this line or something like that. I didn't do that.
Perfect. Okay, so I think we can wrap up in here, just to be a little bit respectful of your time. Chris, thank you very much for this. This was amazing. I think we all really appreciate it. It was wonderful as usual watching you do your magic with your slides. So that was really cool. And I think our students got a lot of that, and with all the questions, I think they can get it in there. For anything else, you guys can follow him on Twitter. He's Krist W at Twitter. And I think we have seen his website and everything. So you can send, and there his website is kristw at yellowpigswithz.com. So Chris, thank you very much.
Thank you, John. Nice to meet you, everyone.
See you. Bye-bye.
Bye-bye.